Hi. The I got these from the IPC. It's BoseBuild Headphones, and I went through the app and built my own pair. You can see they're really cool. They're Bluetooth, so I don't have as many wires anymore. I can change. I don't know if you can see or hear like the voice, but just turn that off for now. And what's cool is they sent me an extra pair. So what they are asking me to do to see if I can come up with some kind of student project. What is really cool, so these are the headphones that are not put together. You can see how they compare to these, like assembled headphones. But what's nice is they have a lot of like really good explanatory text just built into the headphones. So you can see like RGB Drive, some model number information. Over on this one, you can see the amplifier, the antenna, the switch. You can't read that in the metal, but it's Bluetooth module. So I'm going to see if I can just open these up and get a better look at the circuit boards themselves and see what I can learn. I've got this view here with my face. I've got a set of Wera screwdrivers that I'm going to try and use. So looking at this one, there's a couple of just screw holes like around here. Try and get into. Now some of these are Phillips, but some are kind of the tri-head looking screws. So I'm gonna see if I can find something to get into those with. Might not be able to get to the left one. It's okay. The right one I think has more interesting stuff. What I'm really interested in with these headphones is they're like a complete. Now I've been doing Arduino projects and electronics for like 3 years, and what's really interesting is like this is a professional product. There's one more right here. And like it has like the same kind of things that I think about for my Arduino robotics projects. I imagine you think about with something like this. So like I'm you're gonna have a lot of the same things going on. So I'm wondering if I'll be able to recognize a lot of stuff. Alright, got those. You know what I'm gonna do? I just got one of these solder mats. And it's got little let's see, how does this work? It's got little storage spaces, and screws and stuff. Yeah, just put that there. Okay, so there's another one. Okay, so I think I got mostly into this one on the right. I'm trying to see what else would be holding it together. Well, let's just see if I can get like a flat edge. Get a bigger flathead screwdriver maybe, and just kind of pry it open. Yeah, so the left one, I wasn't able to get all the screws out because it has some of these tri things. I'm just thinking like, yeah, there we go. I hear that plastic cracking. Which maybe, isn't the absolutely correct way to open something like this, but let's see, what else is holding it together? I wonder if there's something underneath this sticker. Or if I just need to power through. From here. There we go. Okay, that was it. Okay, so pop that open, take a closer look. So that's really nice. So it kind of came apart. This is what I was kind of worried about, so let's just think about this. So yeah, so you can see the speaker output. How am I going to show this? Move my file out of the way. So these two wires, this is just the speaker connection, and I can see red and orange here, and I can see red and orange inside of this case with the speaker, right? And so they're connected to these plus and minus points on the board itself. So yeah, I'm not going to cut that right now. I'm just going to leave that to the side, and I'm going to take a closer look at this board, see if what I can do with it. I can get it out. Okay, so yeah, so you can see this is a lot of, these are all these pins that are going over to the other headphone pair, because what's interesting is like they're talking to each other, or they're using, like this Bluetooth module is going to be sending data that both of these speakers need. So there's a lot of cabling going around and over to the top to get to this one. Yeah, so I haven't looked at this before. Okay, so I see some Phillips here. I might just take those out to see if I can get the board out. You got your switches. You can kind of see. Oh, it might be, it not be. Oh yeah, this is the switch. So if I click that, yeah, so you can see what it looks like when I switch that on. All right, I'm just gonna turn that off while I'm poking around in here. My suspicion is that it's not a hard power switch, because you can see like the lights stay on for a second, and that might be a capacitor, or I'm assuming that there's like that it's on and that there's some digital action to turn everything off. Not that it's like a hard analog turn off. Let me just undo this. Let's see if that's enough to get this board out. Yeah, that was it. Okay. So, let's see. So of course, we've got all these. I'm just gonna throw these, and I've got another little bin I could put little plastic bits in. So take this stuff out. Yeah. So that's just a microphone. So what I'm looking at here, this little piece of plastic has these little dots on the outside, and this is where they say like the microphone. So if I look on the bottom here, do I see a microphone in that position? Well, what do I see? I see this little chip, and I'm not entirely sure what it is, but we can look that up. It might be a microphone. But yeah, you see double-sided board, really thin. Here's an RGB. So that's going to be on the outside of the headphone, right? It's glowing up this whole thing. There's probably some material properties there. That's nice. Okay. So let me think about how I might try and take this apart. See, so I don't really want to cut anything right just yet, but let me pause. Can I pause this? Let's see, let's do together here. All right, well, it's going to be I'm just going to take a closer look at this board just to think about what's going on. Okay. Yeah, what's nice is that these things are pretty labeled. Like, so you see the Bluetooth module, amplifier, and the output of the amplifier is going to the speaker, right? Because what's happening is there's going to be some audio stream being sent to the Bluetooth module. That data is going to be turned into an analog signal somehow. So this chip might be a digital to analog converter, and then that could go into the amplifier and out to the speaker. I'm imagining that's what's going on. And then probably there's signal wires going from here to the other speaker. Like probably this guy is routed up to there. There's a whole mess of wires, like so many different, I don't know why all that is there. And then even on the other side, so there's just like so many connections. And then you even numbered them. Is it 18 total? Maybe 18 total connections between each headphone. Yeah, it's pretty serious. Well, because if it was like a digital communication protocol, you'd only need like at most like 3 or 4 wires to send all that data. So I'm not sure what these 18 connections are. Maybe duplicate power, duplicate ground wire, so that there's enough current being able current source over there. Let's take a look at the back. So look at all this, tons of test points. Absolutely mad. It's very humbling, actually, to see so many test points. All numbered up to 91, 93. I'm just trying to look for the biggest number I see. Is it 93 test points? All on the back here. So those things, that's wild. So this board will probably, it plugs in to a bed of nails, they call it, just like a bunch of pogo pins like standing straight up like this. All those test points make contact with another piece of electronics, and then that piece of electronics is like running a program to test every single function to make sure that this thing works. That's absolutely wild. 93 test points for, I'm imagining it's just as much on the other one, right? So the amount of thought and testing that went into this is pretty wild. Yeah, so I'm not sure. I just see the RGB here. Look at this one right here. This is very interesting. I can see it on these through-hole pins. 1, 2, 3, 4, 5, 6. Is that a programming header? I have one right here. Is it FTDI? So let's see here. I got this. It's 1, 2, 3, 4, 5, 6. So yeah, so FTDI is this external programming protocol. This is a little SparkFun board I've used to program a couple different projects before, but I'm wondering if is it as simple as that? Are they using the same FTDI breakout right there? It's interesting that it's right next to the USB input. Because sometimes I did this for a project. You have a USB port, but you don't have any data on it. You just do the power, so that you don't give easy access to the programming and the data that's on your project. So I was wondering, I hooked this up to a serial port and I didn't get anything. No data was popping out of it. So I'm wondering if that's just a power port. This looks like and that just might be some charging ICs. Don't know where the battery is. It might be on the other headset. But yeah, this looks like a big old inductor. So I think this is probably just some charging infrastructure. And then these 6 pins right here might be the programming header. I'm just trying to look at the traces. There's definitely a test point right there. It's interesting, these test points. There's test points on the top, but they don't pop out as being copper. They're kind of like beige. You see them definitely a lot better in the back. Okay. Let's see. Well, is there anything else in the back before I go to the other headset I wanted to think about? So, yeah, there's an unpopulated transistor. You know, so pretty much everything is populated. There's a couple of things that aren't. Will be interesting to maybe look to see if I can read this QR code. If that says anything. Yeah. Wow. Okay. Let's see if we can get into this other headset. So the battery must be over here, even though the charging infrastructure is over on this headset. There's no battery over here, so it must be over here, unless they embedded it in the speaker, but don't see how they would do that. Okay. Yeah, so yeah, it looks like it just has two of those tri-headed screws. Let's see what I got here. Let's try this. I've got a hex-headed screw. Maybe it can do the business. Not quite. Let's go with a small flathead. See if I can finagle my way in. Come on. Okay, let me see. I've got some stuff behind me. I'm going to look for eyeglass repair stuff. What's so nice about these Bluetooth headphones, I can stand up. I don't have to worry about pulling my computer anymore. Yeah, I need to get one of those iFixit kits. I don't have a tri-headed screw. And, you know, it's just intentional on their part because they don't want people like me getting into this kind of behavior. Come on, I feel like persistence is going to be key here. Let me think about a way to do this. It's a knife tip. Nah, that's just suspicious. You know, maybe this with something like this. Well, at least we got this one out at the bottom, so let's just see if we can crack it. I don't want to do that. Let me think. Fucking try headed screws. And you know what you can do at this part? I'm not going to be bothered to edit this. So what you can do is use the Google plugin, hit D a couple of times to speed through this, and then you can slow down to the. That's so funny. I'm not going to edit it anymore. I'm just going to tell you to get your own speed up protocol. That's so funny. Because you know you should be doing it anyway because you can process information faster than I can say it. So control the rate in which you hear me, and I don't have to edit. Win-win, huh? Such a bummer. Do I just drill through with the popular? I just got this. I actually used it, but there. Let's see if I can do. Fuck it. That's a bummer. Okay, just go for it. God damn, so tough. How to remove tri-wing screws. Yeah. Step 1, purchase a tri-wing screwdriver. Try with small Torx or hex screwdriver. Right. Yeah, that's what. Let me see. Let me try that again. The thing is these are smaller these tri-wings are even smaller than the ones I have. Yeah, I have to get an iFixit kit. How much is an iFixit? There we go. Get me to the iFixit store. Come on. I can get a $75 kit or a $35 kit, or the Repair Business Toolkit for $275. Let's see. Here, why don't you guys take a look here? Loading up a little slow. Do you see a tri-head? I guess it's that it. Oh yeah, there they are. Yeah. Yeah, this will definitely be a worthwhile investment to get something like this, about this one. Yeah, that's a nice kit. I don't really need though, but it looks nice anyway. You see, I don't think this has everything I could possibly want. It's got the try. Yeah, I might as well go for the mega kit. Look at this with all the bits, all the possible heads. Because you know what I'm seeing, like these guys, those kind of like inverse hex kits, I think I can use to open up my Game Boy, which is a project I've been thinking I wanted to do. So I might just go for this $75 kit. Torx, tri-point, triangle, 1/4 inch, 4mm. Yeah, this is probably good. It comes with two heads, two handles, I mean. So that's good. Alright. It'll take a while for that to come in though, so in the meantime, what am I going to do? Well, in the meantime, what can I do? I can investigate more on this side. So, right, so I'm going to order that iFixit kit so I can pop this guy open. Then we'll have the complete electronic system separate from the mechanical housing. We can analyze it a little more closely. But in the meantime, what we can do is start trying to analyze this right headphone circuit a little bit more. So definitely have the Bluetooth unit, which is probably the most important thing. Just kind of a cursory glance on the other side is, looks like there's only the RGB drive and the aux input and a button. Oh, that could explain why there's so many data lines. The aux input, yeah, that makes sense, because then what? You have RGB drive, aux input, and a button. So you've got digital line, a bunch of analog lines, maybe three or four analog lines, and an RGB drive, another digital input. In addition to driving the speaker, the power, so kind of 18 pins, I think, was it, connecting, 18 pins at the top of this, going through this cable to go over here. Starting to make more sense when you have that context. And if the battery's over here, then you've got, battery charging circuitry that's got to go that way. These little buttons kind of break out. It always blows my mind. The Game Boy does this too, but you got these little surface mount buttons, and then you got your mechanical engineer makes some little bits of plastic rubber, just with decals and kind of stuff like that, and it kind of brings the button to life, like, just wouldn't look the same. It's just surface mount buttons, but this kind of molded plastic really makes it a lot better. So yeah, I should be able to turn this on. And you can see, okay, so yeah, you can see the LEDs here. Oh yeah, so that's it, trying to pair Bluetooth is what it's describing there. I wonder if on the back here you can see the RGB going. Yeah, so you can see that RGB on the back of the board, and that's what's glowing up the whole side of the headset. That one thing. The little systems that I have. Just thinking about the things I know about this one. I can volume up and down. What's this middle button? The connecting. Yeah, but what will be interesting is to get this whole system all undone, connect it, like pair it, say, to my computer, pair it to a song, and then hook up an oscilloscope to try to see digital signals, analog signals that are flowing through this thing. It's really nice, like, I think it's intentionally well labeled because they are trying to use this as an educational product. So I don't think they intended people to really open it up like this, but just the number of test points, the well labeled subsystems, I think just makes it really easy to kind of poke around and kind of figure some things out. There's no official material on this, so I'll see what I can kind of come up with. Yeah, so I think for now I'll just poke around with it off camera and then figure out what to do after that. Have a good one. Catch you later.